Hello everyone, welcome back to the channel with the brand new series on integral calculus. So I'm planning to start a video series on bite-sized integral calculus where I'll be helping you upon getting a solid grasp of integral calculus in your first year university level courses, and this can also be applicable to your high school courses if you have some integration courses in your high school as well. So in this video series we'll be covering some basic videos on integration, and we'll be diving deep into the fundamentals of integration and also some strategies and tips and tricks that you can use in your integral level calculus courses in order to get a good grade at your university or high school integral level courses. So in this first video specifically, we'll be talking about basic integration and how you can sort of relate these basic fundamentals of integration to the already learned concepts that you have done in your high school or even in the first term of your university. So we'll be talking about integration. So whenever we talk about integration, it's always about integrating functions or integrating curves. So whenever you ask to integrate something or integrate a curve or a function, it's basically asking you to calculate at the most fundamental level. It's basically asking you to calculate the area under the curve. So if, for example, you have this graph that you can see on the screen, you have a graph which is represented by y equals fx, and you can see on the screen as well, it's a curve. And if I ask you to integrate this curve y equals fx, you basically have to only calculate the area under the curve. So it's basically calculating the area enclosed by this curve above the x-axis in this particular example. So whenever you talk about integration, integration is basically taking the sum of something, the sum of all the parts of the curve. So in this example particularly, if I have to again frame it in a different way, if you have to integrate this curve y equals fx, you basically have to take the sum of all the parts of this curve and add them together in order to get the integrated formula or integration of this curve y equals fx. And in the most basic terms, if we also relate this example to the previous example that we did in this video, it's basically again taking the sum of all the parts on this curve is basically taking the area enclosed under this curve. So this is the most fundamental example or the most fundamental definition of integration. I'm sure most of you would already be familiar with this definition of integration as the area under the curve when you would have taken some physics level courses in your high school or in the university term 1, where you were supposed to calculate the distance traveled by a car based on the velocity time graph that you were given, and you just took the area under the curve in order to calculate the distance traveled by the car based on the velocity time graph. So that was basically the same relevance of integration that you did in your high school, which you will be doing in the math level integral calculus courses so far in the university as well. So that was it for today's video. We just talked about the basic understanding of integration, which will also be helpful to get a better grasp of all the new concepts that we'll be using in the math level integral calculus courses at university. And in the upcoming videos as well, we'll be improving upon this existing definition of integration as the area under the curve, and we'll be learning some new concepts related to integration. Stay tuned for the upcoming videos that will be regularly uploaded on this channel about integral calculus. And please make sure you follow the channel to get notifications about the new videos that I'll be uploading. Thank you so much for watching.